Hey guys, how's it going? Alright, so today I want to try and show you something. While following through the game hacking Bible, um, I was messing around with a few things, trying to understand the basics at least, and I kind of got stuck uh, trying to find um, the address of client state. What is client state? Client state is a class that holds a bunch of important information and it's basically the base of everything, uh, at least once you reach a certain stage. And a lot of people just usually go on Haze Dumper and look up the client state offsets or addresses, and they get them from here and they just go on simply copy pasting, or maybe they find a signature somewhere and use that. uh, I don't want to copy and paste anything. I want to understand what happens. I want to understand how to get to this point here, and therefore I dug into it. It was not easy without much knowledge at all, but I eventually figured it out. At least I think so. So the best way for me to test that theory out is to try and explain it to you, and if I succeed, that probably means that I learned something, and well, I can go on with the next task. So client state is a class within the source engine uh, that is responsible for a lot of things. And since we have Source Engine publicly available, you might as well check it out and look it up there and see what's in there. So that's what I did. I just cloned the project and I'd opened it up in my favorite IDE, and that would be C Lion. And then you're gonna just find it in um, engine base client.c++. And as you see up here, we're gonna find CBase. Where is it? CBase client state. There we go. So our main objective here is to figure out what it does, or at least figure out a few functions that might be interesting, and then go to IDA or anything else like Ghidra, and figure out if we can get the address to it. Um, Alright, so one of the easiest way to do it is by checking out those functions here. So we find any member functions like these ones here, and we're gonna want to look for strings. Those are easy to look up when statically analyzing or decompiling libraries. We're talking about the engine DLL, and yeah, let's go and do it. So there's a whole bunch of those, and not all of them are gonna be good. So you wanna be looking out for strings. You're gonna wanna look for functions that are called outside of the class itself. So somebody else calls these functions, and and yeah, we'll go from there. So if you start from this one here and you search it up a little bit, you'll see there's a lot of calls, but I'm not really seeing any direct calls to it. Yeah, so I went through a bunch of these until I found something that's interesting, and the easiest one is probably the forceful update function, and it's this one here. As you see, it's got a string in it, and if we look it up and see who calls it or where it's used, you're going to see 4 different places where it's getting called. CL is going to be our client state, and that's good because we have a bunch of regions where we can disassemble and figure things out. So let's go ahead and do that. I'll show you how to do that. So you're going to want to copy the string, fire up IDA Pro or the free version like the one I have. Then you're going to want to Alt T and search for the string. I also selected find all currencies so that have a better overview. Click OK. It's going to take a while. Already have it loaded up here, so we don't waste any time. And these are all the references to it. So I'm simply gonna open up this one here, I believe. Yes, that's the string itself. And let's see where it's being used. Press X, click on this one, press X to see the cross-reference list, and click OK on one of them. Probably it's just going to be this one here, because if you go back to the code and look it up here, search for the string, you'll see it's only used once in the whole code base. So that's good that we only found it here. Now you're going to find a whole bunch of instructions, and who knows if this is the right one. If we look at the original code here, we see it's a very simple function, and we don't really, well, let's see if we can find the same here. If you have the Pro version, you can hit F5 and decompile it. However, I don't have it, so way I found out to decompile it is by simply firing up Ghidra and loading up engine DLL, and then you simply take the address here, go over here, press G, pass the address, hit OK, and here's the function. On the right side you'll see it as decompiled, and well, it kind of looks like it's the function we're looking at, doesn't it? Let's see. It's an if, and then we're calling def message. It's an if, we're calling def message. Kind of looks right to me. And if we look at the disassembled code here, we have the call to def message as well. So we're pretty sure that this is the one. Now, what you're going to want to do is check for who's calling this function. Now here you might not have the forceful update label. That's why that's because I placed it there. You want to right click, rename, you can add it there. So you're going to be finding the same label everywhere it's used. It's easier to read. So you're going to want to click on that one, press X to cross-reference, and there's going to be 1, 2, and 3 calls to it. Again, if we go back here, search for usages here, you're going to see 1, 2, 3, 4. You don't necessarily find all of them in there, but that's good enough for us. I mean, we got 3 calls to work with, and that's good. So you can start off from the first one, and remember, it doesn't necessarily mean that all of them are going to be right. They could be wrong, and so let's just go off the first one, which I happen to know it's not going to work, but we might as well do it anyway to show you how it's done. Let me go back here and delete a whole bunch of lines because I want to do it from scratch. And I have a base signature that I simply copy pasted from the internet, so it's a magic signature. I don't know where it came from and I don't want to use it, but I'm gonna use it as a baseline to show you that we're actually getting the good one. So just to show you that, I'm gonna compile it and I'm gonna go ahead and fire up the injector, and oh boy, there we go, we got it. Let me disable my antivirus real quick because this one's gonna bother me. Okay, good. And inject, and we have the client state here. I'm gonna take that as a base from here. Now what we're gonna do is go back to IDA, and this is the call to the function as we see it here. Now in here you see the function does not take any parameters. However, it's a member of base client state, sorry, C base client state. And this means that whenever we're calling it on an instance of client state, and it's basically going to be a this forceful update call, and what we're looking for is this. So back here, what happens is that when the compiler does its job, it is going to show up like this. This pointer is often going to be ECX, and we do see ECX over here, so that's good. So how do we go from here to having an actual address of the client state? Well, this is a pointer to client state, and the pointer is put into the ECX register, which is passed in as a function parameter in forceful update. We know there's no parameters, but that's how the compiler works. Passes this pointer as a first parameter. That's good enough for us. We don't really need to know exactly why that happens. We just know it does. So we're interested in this one here. And what we're going to want to do here is we're going to take a signature of these instructions that we see here. So looking on the left side, you see the opcodes, and if you do not see those, you go to Options, General, and you add a number 6, 8, whatever, and they're going to come up over here. So at this point, we want to take the we want to go over here, right? We want to have an address that's somewhere here. So we're going to take a whole bunch of lines. These 4 lines are going to be good enough, and we're going to build a signature off of this. So you can do it in 2 ways or multiple ways. The first one is by hand. You write down those bytes, and the other way is just by using a plugin such as SigMaker, and that's going to do it for us. Create IDA pattern from selection, and here we have a signature that we can later use. And now you're going to wonder what these question marks are, so I'm going to try and explain what they are. So what you see here is an instruction, the move instruction, which corresponds to B9, as we see over here as well. And then you're going to find 4 bytes, which are going to be part of the, or they're going to be the address to client state. And so what you're actually interested in is making a signature that does not change when the game restarts or whenever something happens, and therefore you know that this opcode is not going to change. However, the pointer is going to change every time, so this is not going to stay static the whole time. So you kind of want to tell your SIG scanner not to look for these opcodes here, which will change, but only look for this, then a bunch of bytes that you don't know about, and then more. So what's going on here is that we have B9, and then we basically wildcard these ones here as question marks. Then you have a call, which is E8, then another address to the function itself. So this one can change as well, so we wildcard it out. Then we have a pop 5D, which doesn't change, and then we have a return 8, and these two don't change either, so you're going to find them here, C20800, and that's good for us. We're going to take it, copy it, and we go back to our code. And if you're followed through the game hacking Bible, you're gonna probably have seen the scan signature function. You probably built one yourself or adapted one, and I'm not gonna be explaining how this is done. You should just follow the steps and learn. However, you're gonna have this one here, and we're just going to duplicate this, call it address to. We're going to pass in the new signature here, and we're going to duplicate this line, ClientState to address to, and then we have a +1. What is this +1? So we go back here. With the signature, we get to this point here, right? It's going to possibly return an address to this region of code, this opcode B9, but we're not interested in the address of move. We're interested in the actual address of this pointer, which is this one here. So what we do is we take this address, add 1, so we're here, and then we're gonna have the correct address. And so that's why we have the +1. You're gonna want to build it, and then you can inject it. And as I told you before, it doesn't work. It's not exactly the same one as the baseline that we had. That's okay, don't despair. It's a trial and error game here. It's going to take you a lot of time to go through all of the possibilities. You're going to fail a lot, but eventually you'll find one. And as I mentioned, we had several calls to forceful update. So let's go back in there, press X again, and let's go to the next one, like this one here. And we're gonna see the same thing, ECX being the this pointer. And so we're gonna just take a bunch of lines, and we're gonna generate a signature, edit, plugins, SIGMaker, create IDA pattern, and get this. Now the length of the signature doesn't really matter, so long as it's enough bytes to make it so that the opcodes you're comparing or looking for are unique in your module here. And otherwise you might find different regions of code and it's not going to give you anything useful. So yeah, we copy that again. We go back to CLion and duplicate this line, number 3, add the signature here, 3, 3, build, and inject again. See what we got. Good. So it looks like the first one, so that's pretty good. There are 2 different signatures, but they do return the same result, which is what we're expecting here. The address of client state should not change. Yeah, shouldn't. And another thing, what we're doing here, we're just casting the value that we found, and then we get the actual value because it's a pointer, it's this pointer. So we're just gonna look at the pointed value, which is gonna be the address itself. And let's go ahead and do another one. Again, X, last one here. We see ECX again, that's good. Got a whole bunch of those. Edit, plugins, SIGMaker, and this. See, I don't even need to take all of this. I'm just gonna do that. And go back here, duplicate, you know the drill, copy 4, 4, and 4. Now build it, inject it, and we get it again. So 1, 2, 3, just one didn't go through. I don't know why. Maybe I'll figure it out one day. But okay, let's say that you didn't want to go through that single function that I showed you before, the forceful update. Let's try and find another one. So what I did offline was just go through all of these or most of these and see which one are good or which one are not as good. And I found a second interesting one, which is send string command. And this one does not have a string in here. So you might wonder how we get to this function itself. Well, one way to do that is by checking who calls it. And right off the bat, we see that there's one region of code that has a string, hardcoded string in it, demo restart, and even better, right after that, we have another string. So it should be pretty easy to find it in IDA. So same thing, we copy this string here, we go in IDA, and we're gonna look up for this string. It's gonna take a while, so I'm gonna try and just find the first occurrence. There we go. And we know it's contained in here, probably gonna end up here. Okay, so press X on this one here, and it's being used in 2 regions. Well, let's check out the first one. Here we have it, demo restart. However, we do not see the second string as we did here. Remember, there's a recording too, which does not seem to appear here. Well, no big deal. We go back and we had a second one we can check out. And right here we see the second line, which is just perfect, right? We know that we're in this function, and this is the part of the function we're interested in. And if we look at here, we do see ECX again, which is this pointer. So what do we do here? We select this whole thing, and then we generate a signature again and see if this all makes sense. Will it? We'll see. Copy again a bunch of it. Go here, address 5. Build it, inject it, and voila. We have the exact same one again. And well, this is hopefully enough for me to go and figure out the next steps, which is going to be figuring out what client state actually holds, building a class for it, and then using it in game, since now we have a pointer to the client state itself, or actually an address. And hopefully this was helpful for you, and well, let me know if you spotted anything that's off, or if you have any suggestions, improvements I can make, and see you next time. Bye.